So, okay, black holes. When you think about black holes, we need to think about three different terms. What's space, what's time, and gravity. All three of them have something to do with black holes. We're going to talk about them in a few seconds. So, when we talk about space, we need to check just a few details. For every single human being, either if you have taken classes or learned physics or have done a degree in, space, you know the sun. And the sun is our star. It's located in the center of our little galaxy. Well, not exactly. The Milky Way is just a solar system which compounds the sun and just a few planets. Well, it's about 8 or 9, depending on if you consider Pluto being a planet. So we got Mercury, we got Venus, we got Earth, and we also have Mars. Oh wait, that's not the color. So there we got Mars. It's a little bit far away from Earth, but it's still one of the first planets. Then that means it's freaking relaxing though. So, what's space? If you think about it, if you draw lines, up and down lines, you will notice that there is one direction, that is the longitude, and there is another direction, although you cannot see that is the latitude, which are the upgoing lines. Okay, so let's bring that on paper in a more easy perspective. So we got kind of dice here. So we got the first dimension, which is length. Okay, we got that one clear. So when we talk about the second dimension, we got height. All right, so how tall is something? That will be the second dimension. And the third dimension, well, in this case, we got a cube or a sort of dice. That will be depth. How deep is an object? All right, so to make it 3D or three-dimensional. But what if we got a fourth dimension? What does it have to do with time? Okay, let's check that out. So let's think again about that little dice. Well, it's not that well drawn. I'm not an artist. So we got again the first, the second, and the third dimension. As you can see, it's a little bit exaggerated for you to be able to see it clearly. But if you move that dice in a space, you're going to take a time, right? Yeah, a few seconds, let's say 25 seconds to move that, just in case if that were, if it was a physical object. So that would be a fourth dimension, but they can't happen in the same space, right? So you actually need to consider time. So back in the 19th, Einstein actually discovered that space and time were actually linked together, as if you were talking about a network of forces and nature that is embracing all the nature of the universe. So it's amazing. We no longer have space, we have space-time, which is also something. It's not just a dimension, it's physically and virtually something that ties the universe. So think about this. Remember the sun, right? So if you have a massive object, which means that have a lot of mass, a lot of matter, it could be energy though. It will actually depress or make a hole in the space-time. We will curve the time and the space around it. So the question is why? Well, let me explain that. So let's talk about our friend the sun. The sun is cool. It's actually a white star. However, it will be pointless if I draw it in white. However, orange is the color we're all used to. So we already know that it's a massive star, but not so big. It's actually a white dwarf. We got energy, a lot of it. And also we got a huge gravitational area around here. So if I cut on the edges, we will in fact going to see that there is a space-time curvature around the sun. Although it's a small star, for its size, it can hold in gravity 8 planets and asteroids and countless rocks around the space. So why does it somehow curves the space-time? How big does it have to be to do that? So there are a few scientists that have turned this into questions, theoretical questions to understand black holes. So a black hole is very, very similar to our sun. It's spherical. It does have mass. The black holes also have space, time around them. But also they have a high gravitational area around them. That's very important. Let's point that out. And also, they are massive. They have a lot of mass. They have X times masses of the sun. And they also have spirals. So gravity around them is actually curving the space-time. So if you take a look, it looks a lot like a galaxy, right? Because its spirals actually indicate that the black hole is moving. So if we got an object, let's say a little Earth here, let's call it an object. It could be a rock, yeah. It will actually force that object to move inside the gravitational forces of the black hole. Even light can't escape from the gravitational forces of a black hole. So, although protons that are part of light, they can't escape. But how do we take that picture? The picture actually shows the black hole and the area around it. It is called the event horizon because everything far or close enough to the event horizon will be absorbed by the black hole. So everything that closes or everything that gets close enough of the event horizon will be absorbed by the black hole. So why did we see that little crown on the picture? Okay, so this is the black hole. That crown around it, it actually means all the matter that is crossing that safe zone, that is going actually a little bit closer than it should, so it gets absorbed. Why? Because we can't really see a black hole. It's dark. So everything that's going there and it's being absorbed by the black hole is what is being shown in the picture. So that's pretty much about it. This is a very brief explanation. It's actually a lot more complicated than this, but this is it by now, and hope you like it, and hope to have a better explanation pretty soon. I'm sorry about this, but my voice is changing. All right.